Okay, so this problem is on purchasing a car. The car itself was worth $24,000, and the car loses 12% annually. This means each year. So the first thing you're asked to find that growth factor is also called the R value. So like we did in the previous problems, we start with 100%. We subtract 12% from that because we are losing money. So that's 88%. Divide that number by 100. And you get our growth factor, which is 0.88. Now, one of the things you're being asked to do is write the exponential equation. We'll look at that last. So beginning of this problem, and again, we did something very similar to this back in chapter 1. In year 0, the car is worth $24,000. The car will be worth 88% of its value at the end of 1 year. So we're going to multiply this by our R value of 0.88. So the car after 1 year is now worth $21,120. To figure out what the car is worth at the after the second year, we'll multiply again by 0.88. And you will get $18,585.60. And if you continue by multiplying by 0.8 after year 3, $16,355 and about 33 cents. Now I'm just taking the answer in my calculator and multiplying by 0.88, so your answers may be slightly different than mine because maybe you're rounding first and then multiplying by 0.88. But your answers should be very, very close. I'm going to leave the rest of the table for you, and the question below it is asking in what year will the car be half of its value? So basically, when will the car be worth $12,000? Quite often we do a lot of problems involving half-life, which means we're looking for problems in which the value is going to be half of what it was originally. Now for the equation, it's going to be y is equal to, A is our starting value, so we'll just put SD here. And our starting value for this problem is $24,000. Times the B value. The B value is what is our multiplier, and that's the 0.88. So this would be the equation that we could use to be able to determine the value of the car at any year. So in other words, if I would replace the x with 20, then and do y is equal to 24,000 times 0.88 to the 20th power, if this car continues to lose 88% of its, or continues to maintain 88% of its value each year, that problem would tell me how much the car is worth in 20 years. So in this problem, we're starting with $10,000. And we're looking at a growth of 15% annually or yearly. And to be honest, for an investment, that's just phenomenal. If you can find investments that are making you, 6 to 8%, that's really, really good. Anything above 8% is considered really, really a great investment. So, as we did previously, to find that R value, or growth factor, we start with 100%. We're adding 15% since this is a growth. So we have 115%. And if I take 115 and divide it by 100, it tells me our multiplier for this problem is 1.15. So the stock itself, at the beginning, is $10,000. To figure out how much it's worth after 1 year, we multiply by 1.15. Basically, that's that B value. So after 1 year, the stock is now worth $11,500. To figure out what it's worth after 2 years, we multiply by, again, 1.15. That's kind of B value where we multiply by the same number over and over again, like an exponent problem. So this is the value after 2 years. This is the value after 3 years. And again, like the previous problem, I'm going to kind of leave the rest of this problem for you to complete. Now the exponential equation is y is equal to a times b to the x. The a value is 10,000 and the b value is 1.15. So the equation is y is equal to 10,000 times 1.15 raised to the x. So if I had this investment, which would be a phenomenal investment, and I wanted to figure out how much my $10,000 would be worth in 20 years, I could put in 10,000 times 1.15 raised to the 20th power, and that would tell me approximately how much money that $10,000 would be worth in 20 years. All right, so in this problem here, you're being asked to figure out in what year will the two schools basically change in population, in the sense that the smaller school now becomes the larger, and the large school becomes the smaller. So in the first school, population starts out 900. It's actually increasing by 12%. So in other words, if I would multiply this by 100 to turn this thing into a percent, it would be 112%. So the 12 in this is actually the growth that's occurring each year. So I multiply by 1.12, and then that answer is 1,008 students. Multiply by 1.12 again. So we're looking at 1,128 students. And in year 3, they're at 1,264 students. And you continue on the table. In the second table of the school, I chose 2,000, which is really close to North High School. And this time the population is declining. So basically, each year the student population is about 88% compared to the previous year. So I multiply 2,000 by 0.88. 1,760 students in the school, and then 1,548 students the next year. If I match up the third year, 3 years, 1,362 students. So I got putting a decimal point in this, nothing with tens and hundreds, because we're talking about student population, so we're not going to have 3/10 of a student. So I just wrote down the whole number part of the answer. So they're definitely getting close to each other. So I anticipate probably in year 4 or 5, the schools will have equal population, and then the smaller school will become the larger school at that time. The last problem, we're doing some graphing. So if I use the equation y equals 3 times 2 to the x, stick in 0, I'm going to get an answer of 3. That should hopefully make sense that the a value here is actually telling me where I'm starting, which is at 3. If I stick in 1, it'll be 3 times 2 to the first, and that's going to be 6. And hopefully that makes sense because my multiplier is 2. So the next answer, 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. But again, that multiplier of 2 tells me the answer is going to double again. And it will continue to double because of the b value. So the graph itself stops at 30. So we're not going to be able to graph 0 through 3. So 0, the answer is 3. Now, 1 at 6. 2, the answer is 12. And then 3, the answer is 24. So the graph, exponential graph are actually, they're curved, so it looks something like this. If I would go back and put in, let's say, -1, we'd get an answer of 1.5. So I'm going the other direction, so it's going to be half as much. If I stick in -2, half of 1.5 is 0.75. So what's happening here is the answers are continuing to decrease. If I keep taking half of a number, half of 0.75 is going to be like 30.375. If I continue to do that, I'm never going to get to 0 because even when the number gets small, really small, I take half of that. Half of something is not going to equal 0. So this graph here approaches the x-axis but never touches the x-axis. It never becomes negative because when you divide a positive by 2, it's always a positive answer. That's the last problem for this handout. If you have any questions, make sure you ask.